So group 8 elements, as you can see the periodic table. So the group 8 elements, which include helium, neon, argon, krypton, xenon, and radon. These are the group 8 elements. These are also known as unreactive elements. Why they are known as unreactive? Because they have complete shell. When we check the structure of helium, the nucleus, this is the nucleus of the helium, which contains 2 proton and 2 neutron, and helium is having only one shell, and in this shell it has only 2 electrons, and first shell maximum can hold 2, and helium is having 2. That is why helium does not tend to lose or gain electron, so it is unreactive. When we check neon, the elements after helium, which is having 8 electrons, so first shell it will have 2 electron, and the second shell it will have 8 electrons. Total there are 10 electrons, but number of electrons in the second shell are 8, which make it stable configuration. Again, when the element is having complete shell or 8 electron in the last shell, it is unreactive or does not tend to react. So helium, neon, argon, same thing. So they all have complete shells, that's why they're unreactive. For this group, what you have to learn, you have to learn the uses for helium, neon, and argon, only 3 of them. So helium, where we use helium, it is used in a weather balloons, in a weather balloon. Why we specifically use helium? Why we specifically use helium? Because number one, it is unreactive, and number two, it is lighter than air. So unreactive and lighter than air, these are the 2 reasons why we use helium in a weather balloons. But the question is, why hydrogen is not used in the weather balloons? What is the reason for that? Hydrogen is also lighter than air, but why we don't use hydrogen? Yeah, the reason is because hydrogen is reactive. Hydrogen can catch fire, explosive. Yeah, it's very reactive element, can explode. So these are the reasons why we use helium as in the weather balloons. Neon, yeah, if it's a small amount, it will give pop sound, but if it is greater in quantity, that it will burst out. Neon, the use of the neon, it is used in lasers as well, and advertisement lamps. Or neon lamps. Advertisement lamps or neon lamps, because of space I just write neon lamp. And argon, it is used in a filament bulb. So helium is used in weather balloons, it is unreactive and it's lighter than air. Neon is there, it's used in lasers or neon lamp, and argon is there, it is used in a filament bulb. Like these bulbs are not common now because of low efficiency, but these bulbs, the near tungsten or filament bulb, so there's a tungsten filament inside. So what happened if it was oxygen or air was there, the air or the oxygen which is present in the air will react with the tungsten, and it will might reduce the strength of the tungsten or the filament. So to avoid this, Yeah, so it will react, it will reduce the strength of the tungsten because it will form tungsten oxide. Yes, Hashim?
Sir, we should only memorize the uses of these gases,
Yes, only you have to
or should we
memorize.
also memorize the properties?
You just have to memorize the uses of these gases.
All right.
So we use argon. Why we use an argon? Argon provide an inert environment which make this filament unreactive or does not react with the filament. So these three gases only you have to learn the use: helium, neon, argon. Helium is used in a weather balloons, krypton is used, neon is used in a lasers, and argon is used in a filament bulbs. Why does the glass explode? That's because of the heat. Because what happened? These filaments, no, the basically what happened, the tendency for the glass allow the infrared radiation to pass. So that's why this is made up of glass. Glass is having a tendency to stop a shorter wavelength. Like example, this is not relevant to the topic, but this is just an example. Like if you park your car directly, like not under shade, if you park your car and it is exposed directly to the sunlight. Example, these are the windows. So what the radiation which are coming from the sun, they have longer wavelength, and as they have longer wavelength, the longer wavelength can pass through. That's why these radiation enter your car. But when the objects which are inside the car, like example, the seats are there, seats covers are there, door handles are there, when they absorb energy and re-radiate or give out energy in a shorter wavelength. So shorter wavelength cannot pass through the glass, longer wavelength can pass through the glass. So that's why the car will become hot if you park your car directly in the sunlight. But in case of the bulb, what happened? If you, this is a filament bulb and here is a filament. So this filament is producing longer wavelengths. So longer wavelengths can pass through the glass. That's why the glass is not exploding even the temperature is about 3000 degree centigrade. Yeah, greenhouse effect. Yes, Yusuf.
Sir, why the radiation in the car is short, not long like the sun?
Not radiation, because it's not emitted out from very hot object. When very hot object emit out radiation, it will give a longer wavelength. When small objects or object at low temperature emit out radiation, the wavelength will be shorter.
Okay, sir, thank you.
Is it clear, Salman, your question? The doubt? Look, why the bulb, the glass of this filament bulb does not explode, because the glass can allow longer wavelengths, because the wave is having also a property which is called a wavelength or length of a wave. So if you have any glass, glass can allow longer wavelengths to pass through. So longer wavelength can pass through. So if I have a filament which is inside this glass, this filament will produce a longer wavelength and these longer wavelengths can pass through. So glass does not absorb too much longer wavelength. That's why it does not explode even the temperature is too high. If the glass will trap, like example, if the shorter wavelengths were given off, then the glass will not allow this radiation to pass and the temperature inside the glass will increase. Then the glass will explode due to high air pressure. Wavelength and this property you will learn in physics unit 3. The length of the wave is called a wavelength. This transmission of energy is in the form of wave and the length of wave is refers to wavelength. I want you to copy this part for group 8 or 0 group elements. Recording, don't worry, I just pause the recording. When you're copying something, So transition metals, why we call the term transition or why we use the term transition? Because for transition metals, compared to normal metals, the transition metal electrons are not stationary in one shell. Actually, their electrons are continuously jumping from one shell to another. In normal elements, it does not happen. In normal metals, it does not happen. Like if I draw the structure of sodium, so sodium, this is the nucleus of sodium. The first shell of a sodium, it contains 2 electrons. The second shell, it contains 8 electrons, and the third shell, it contains 1 electron. So this is a normal structure for sodium. But the number of electrons in each shell remains same. It does not change. Like it's not like this electron can jump to higher level. No, it does not jump. The number of electron in the second shell remain 2. The number of electron in the first shell remain 2. Number of electron in the second shell remain 8. Number of electron in the first shell remain 2. And number of electron in the last shell, the third shell, remain 1. This is normal metal. But what happened in transition metal? As the atomic number increases, the number of the shells which are used also increases. If I take example of iron, Fe, so iron is 26 and 56. So as the number of the shells increase, the distance between the shell decreases. Like the shells are relatively closer to each other. Almost the shells are overlapping. So as the number of the shell increases, the distance between the shell decreases. So these electrons which are here, these electrons, because of small gap, they can move between the shells. They can move from one shell to another easily by themselves. Why they're able to move easily? Because the distance between the shells is smaller as compared to normal metals, in which the distance between the shell is too much, so the electrons are not able to jump from one shell to another. So the transition metal, the name transition is because their electron transit from one shell to another. So their electron number, the number of electron in each shell is not fixed. It might change. And due to this reason, in normal metals, the distance between the shell is too much. As the distance between the shell is too much, the electrons are not able to move from one shell to another. But in case of transition metals or transition element, the shell actually overlapping with each other. When I use the term overlapping, means they are very close to each other, So as they're very close to each other, electron can jump from one shell to another easily. As the electron can jump from one shell to another easily, that is why sometime the iron can lose 2 electrons, iron can have +2, sometime the iron can have +3. What is the reason why sometime +2, why sometime +3? Because if 3 electrons in the last shell, then it will lose 3, all of the 3 electron, then it will be +3. If 2 electron in the last shell, it can be +2. So the number of the electron in the transition element are not constant. It changes because the electron transit between the shells. That is why they have variable oxidation number. Or charge or valency. But in case of sodium, always, like example, when you draw sodium, the sodium will always have 1 electron in the outermost shell. So it will lose that 1 electron and it will always form sodium as +1. But what happened in case of iron, when I draw the structure of iron, the shells are actually overlapping. So as these shells are actually overlapping with each other, so as the shells are actually overlapping with each other, example, if electrons, like example, if 2 electrons are here in the last shell, but one more extra electron jump from lower shell to higher shell. So how many electrons will be there now? They will have 3 electrons. So when these are metals, so if it will lose 3 electron, what will be the valency? The valency will be +3. If another electron jumps from lower shell to higher shell and it lost that electron, so what will be the valency? +4. If another electron jumps from lower shell to higher shell and it loses that electron, so what will be the valency? The valency will be +5. So because they have variable valencies or variable oxidation number, why they have variable valency or variable oxidation number? Because they don't have fixed number of electron in the outermost shell, and electrons are free to move or jump from. Yeah, it does not have a fixed group. That's why when I show you the position of the transition metal, I did not mention that transition metal belongs to group 1, group 2, group 3. They are just placed and their group number is not specified. You can see here in this figure, you can see for transition metal, these are the transition metals. There is no number written on them. Why there is no number written on them? Because they don't have fixed number of electron in the outermost shell, or they have different or variable valencies. So metals in this part are known as transition metal. Yes, Hashim, you use option raise hand. What's the question?
Sir, how will you know that when the electron has jumped from one shell to another?
How you will know that? They will mention in a question, they will specify that it is iron 2 chloride. So if it is iron 2 chloride, it means how many electrons the iron lost? It means the iron has lost 2 electrons. Same way, if I say iron 3 chloride, so what does it mean? Iron has lost 3 electrons from its outer shell. So this Roman number, which is written beside the compound, will decide the Roman number will decide that what is the valency or oxidation number.
Sir, we can't hear you.
Yeah, you cannot say, you can identify only from the name that how many electrons it lost from the outermost shell with the Roman number which is written. Look, I'll repeat what happened. Like in a group 1, if you have sodium, so sodium is having 2 electron in the first shell, 8 electron in the second shell, and 1 electron in the last shell. And the gap, the distance between the shell is too much. The electrons are not able to jump between the shells. So electrons remain, like only one electron remain in the outermost shell and it will lose that electron. That is why in case of sodium, the valency is always +1. But what about transition metals or transition elements? These transition elements, because their shells are actually overlapping with each other. When I use the term overlapping, means they're very close to each other. So as the shells are overlapping with each other, what happened? Example, initially there are 2 electrons in the outermost shell. So if there are 2 electrons in the outermost shell and metal tend to lose electrons, so what will be the valency? The valency will be +2. But because the electrons can jump from one shell to another easily, so if one more extra electron jump to the final shell and then it is lost, so what will be the valency? Because now 3 electrons are lost, so valency will be +3. Same thing if another electron jumps in the shell and it is lost, so what will be the valency? The valency will be +4. Because the number of the electron in the outermost shell are not constant or fixed, that is why they have variable valency or variable charge. Sometimes some have +2, +3, +4. It can have maximum till +7. Is it clear? So you have to learn the properties for transition elements as well. This table, the physical, when you compare the properties of transition metal with other, they are much harder. They are much harder. They have high tensile strength. High tensile strength means you need greater amount of force to break them. That means high tensile strength. They have high density, high boiling and melting point, and many of their compounds are colored. So they form colored compound. This is also a characteristic of the transition element. Group 1, 2, 3 compounds are white solid. Like example, if I say what is the appearance of sodium chloride? It's white solid. If it's solid, it will be white. What is the appearance of calcium oxide? It will be white solid. What is the appearance of aluminum bromide? It's also white solid. Why? Because group 1, 2, and 3 elements, they're all compounds are white solid. But if it's a transition element, their compounds are colored. You already learned, like example, if you have copper sulfate. So what is the color of the copper sulfate? It is blue in color. If you have cobalt chloride, then it is pink in color. Then in terms of chemical properties, they are less reactive. They have excellent corrosion resistance, means does not rust. Corrosion means formation of oxide layer on the surface. So they don't react. So that is why it does not form an oxide layer on the surface. And they show more than one valency. Example, iron, it can be +2, can be +3 or so on. Them and their compound are useful catalyst, and some are very strong magnetic materials. The magnetic part, no need to mention the magnetic part. Yeah, copy this.